This is part 6 in a series of videos in which I'm building a linear supply back-end to a Raiden RD6006 based power supply. This is so I can compare it directly with a version of that supply that I built using an off-the-shelf Chinese switching supply. So to build this, I am rewinding two 225 VA transformers. I'll be winding them so each gives an output of 24 volts with a 120 volt primary. I'm in the UK, so the reason I've gone for 120 volts is because I'm winding two of these and I will wire the primaries in series. I've got as far as winding the secondary, so this is the first one. The secondary is wound. I've put a good layer of insulation between the secondary and overwound that with transformer tape. I now have to wind the primary, and the primary will consist of 300 turns of this size wire, so it's 0.85mm wire. It's fairly thick, but it is thin enough to be able to wind it in a more standard way. If you watch the previous video, then you know that I used a very odd way to wind the secondary. It was fairly short secondary, so I just used a long length of very thick wire and wound it without putting this wire onto any sort of former. But of course this reel won't fit through the core. This is a 1 kilo reel of wire, but even the smaller reels would probably not fit through this. Now I could wind this onto a smaller reel, but as I mentioned in the previous videos, I like to keep the wire as straight as I can while I'm winding it. Now in my videos I'm giving ways that things can be done. I'm not saying this is the only way, I'm not saying it's the best way. I've got different ways of winding transformers depending on the approach that I'm taking. In this particular instance, the method I've decided to use is one I've used before and it works very well. And I make up one of these. So this is a former to hold a length of wire. This is kind of a similar way to the way that professional toroid winding machines work, in a very simplified form. They work by having a big reel holder that passes through the core of the transformer. That then rotates and winds wire onto its outside surface from a bobbin, and then the machine rotates that around the transformer while dispensing from that bobbin onto the actual former. This is a similar sort of idea in that what I'll be doing is putting the wire from the reel onto this. This will of course pass through the core, so I'll make it as big as I can while allowing room for the windings. I'll also make it fairly long, that's just to cut down on the number of turns, but if you did this you can make this any length you want. The longer it is, of course, the fewer windings you need to put onto this, and the straighter your source wire will stay. I tend to have a few of these, and the end parts will vary in size depending on the type of transformer that I'm winding. Now on this particular transformer, what I've done is I've taken the length of wire, I've wrapped it around this so that it's a full turn. What I then do is wind this around the core of the transformer I'm going to rewind, and I see how many turns this will give on the transformer core. Now in this case it will go around 7 times, so I get exactly 7 full turns using this method and this size support. So we need 300 turns in total, so if we divide 300 by 7, that gives us 42.8, 43. So in other words, I would need to put 43 turns around this to give me the correct length of wire to rewind this transformer. And then what I can do, of course, is just keep passing this through the center of the transformer. This will keep the wire nice and neat, and it will allow me to wind the transformer without having to put this wire onto a small bobbin. I'll put a few extra turns on. I'll probably go to 45 turns just to give me a bit of extra, because as I wind onto this, of course, the windings might build up very slightly, and the more windings there are on the core, the longer each turn is. Now in theory, having measured this, it's pretty much a single layer on the outside that's needed for 300 turns, but of course on the inside I'll be up to probably 2 layers, because obviously the outside is a lot further around than the inside, so you tend not to get very neat winding. So the windings never come out particularly neat on this sort of transformer, especially when you have several layers. And unlike normal transformers where you tend to do a single layer all the way around and then go around again doing layer by layer, with toroids what you quite often do, and what I'll be doing in this case, is winding in such a way that by the time I get around the first loop, so to speak, then I should have all the turns on the core. I'll also be starting up at this side, so opposite to the secondary output. So what I'll have in the finished transformer is the primary coming out of one side and the secondary diagonally opposite. Okay, so what I'll do now is I'll get 45 turns of wire put onto this, and then we'll look at starting the winding. I won't show you the whole thing, it's a long, slow, tedious process. I'll just show you the first few turns and the last few, but the next thing is I'll get this laced up. Okay, so I've wound enough wire onto the former to give us the 3 full 100 turns on the transformer core. What I can now do is start winding the actual transformer itself. I'll get the first few turns on, we'll have a quick look on camera, but then I'll finish the rest off camera. It's quite tedious to watch this, and also, as with the previous winding, it's very difficult to do with the camera in the way, but I'll show you once I've got this started and give you some idea as to how this tool is used. Okay, so as you can see, I've done the first 3 turns, and it's just a case then of passing this through the core each time, unraveling it as it's needed, pulling it through, pulling it tight. Also, each time you do a turn, it's very easy to get distracted when you're doing something like this. It's quite boring and your mind tends to wander, so I strongly recommend using something like this each time through. Give it a count, and that way you're not going to lose track of how many you put through. You can count them afterwards, but that's a bit tedious. So all you do is you put it through, pull it tight, make it neat, put it back round, and you just keep going round and round until you've got all the turns onto the core. So I'll get this done, we'll have a look at the finished result, and this transformer will then be ready for testing. Okay, so that's the transformer fully rewound. I thought I'd show it before I finished wrapping it. I've left the excess primary wire attached for now, just in case I need to add any turns. I don't think I will. As I say, I use a counter, so I'm pretty sure I've got the right number on there. But once I've got the windings on the core, then I insulate it. I actually use Kapton tape, high temperature tape, as the initial installation, and then I put proper transformer tape on, and then once I've done this, I'll put another layer of thicker kind of a impregnated cloth tape on the outside to give it protection from scuffing and damage. It's kind of hard to explain how I go about winding this. Just in case you are interested, then I'll try and explain it, but if you look at the windings, they appear to be in groups, and that's to take into account or correct the fact that the wires tend to bunch up on the inside of the core, because obviously it's not as far around this part of the core as it is around the outside, and so you need some way to correct that, otherwise you'll end up with the wires with increasing skew around the outside of the core. I'll just try and draw what I mean. It's say kind of hard to explain, but if you've got the core and you're trying to put wires on, if I exaggerate the problem, you put the first winding on and it will be perpendicular to the core itself, but as you put more turns on, if you try and lay them side by side, then what will end up happening is something that essentially amounts to this. I'm exaggerating it, but this is what it will look like, because obviously the outer circumference of the core is greater than the inside. So to correct for this, what I tend to do is wind in groups, and the number that's in each group will depend on the size of the core and the number of turns and the thickness of the wire. So in this case I worked out that I would need 7 per group, That is also why the former that I made held enough wire on each loop for 7 turns. So what I do is I unloop one complete turn of the former, and that gives me 7 turns, and then I can set down each group separately. So what I do is I wind 3 turns on, and then I cross over on the inside. So the next turn, these are all doing this, but on the next turn on the inside I will cross over and go back to this side, lay 2 more down, go back, and then do another one on this side. That has the tendency to even out the turns, so although you can still see there's a gap on the outside, it's nowhere near as pronounced as it would be, and the groups are predominantly perpendicular to the core. It also makes it look much neater, otherwise you get this kind of haphazard look to the winding. Doesn't really matter, it'll still work, but I just prefer to do it this way. It just looks neater, and it also makes the finished size a lot smaller, because the cores, the windings, aren't stacked up the way they would be if it was just randomly wound. Hope that made sense. As I say, it's harder to explain than it is to do. So all I have to do now is finish wrapping this, get it insulated, put the outer protective cover on, and then I can start testing it. When I do the second transformer, when I get to this stage, before I start wrapping it, I will test it and make sure it's matched to this one. So if I need to make any small adjustments, I can do it before I wrap it up. Okay, so in the next video we'll look at this complete, and I'll start testing it. I'll do some full power load testing on it, make sure the ratio is correct, and make sure it performs the way we need it to.